Well, hey everybody. So it's just a rainy night and I'm hanging out on the porch and I thought I'd start doing this NGC 281 full processing video. So we're going to get in pretty deep, gonna throw all the tools at it and see where we end up. We'll be using Cyrillic. I've got 5 nights of dual narrowband session and 1 night of OSC. And on that OSC night, I'm going to see if I can maybe use the stars layer on that and see if I can combine that with the dual narrowband starless. Not sure how that'll work out. One way or another, we'll end up with a final image for sure. We're going to use Graxpert in the new AI version. We are going to take things back into Siril, do the processing, going to do a starless processing out in Photoshop, come back and do the recombination, and when that's done, we're going to take it over into AstroSharp and do the final processing on that to create the final image. So hey, if that sounds interesting to you, stick around. We're going to jump into that next. And so thank you very much for coming by. My name is Doug, and this is Astro AF. All right, so we're gonna jump in, start on this processing. I'm gonna get myself out of the way and I'm gonna focus on the processing itself. I'll be talking as we go through. I'll speed through sections of long periods of application processing, and there may be times when I'm quiet and I'm just working on stuff, in which case I'll throw some music in there. So anyway, let's jump in. All right, so we'll start over here in Cyrillic. But first, here's my sessions. So I had these 6 days of sessions. The first one is my OSC session, and the remainder here are my duo narrowband sessions. If we look over here, my sessions are laid out the same way. So session 1, 2 through 6, and the first session is set up to be an RGB. If we look at that, I've got this set up as an OSC CCD image, so this will be an RGB image. And the other ones are set up as a Duo HA03. So a quick run through on Cyrillic. The process that I have set up for this is that the biases master is going to be subtracted from the flats, and then that's going to be summed in to the stack. The one setting that I have that manages that for all of these sessions is set here for biases subtract, and notice that that's for identical parameters for all layers. So that applies to each one of these sessions. For all of these, I have the file set up for my lights and my biases, my darks, and my flats. So as far as processing goes, the first thing that I will do is up in the Actions tab here, or the menu, is we'll build the directories and copy link these images. So I'll click on that. And that only takes a second. And then the second action is to go ahead and build and run the Siril scripts. So the scripts that are going to run are going to be the OSC processing script and then the HA03 processing script on these others. And I will end up with 3 result files, an HA, an O3, and then an RGB. So we'll go ahead and run that, and this will take a bit, so I will speed through this. Okay, with that, the script is finished. And a new instance of Cyril has been opened up. And it opened up with, in this case, the O3 file. But real quick, let's have a look in the work directory. So here's our results. So these are our 3 result files. So the HA, the O3, and the RGB. Now, one thing I want to do is I want to open up this RGB in Cyril now, and I want to extract it into separate channels. And I'm not exactly sure if I'll need that or not, but I want to have the flexibility to work with those individual channels. And, so I might end up not using them at all, or I might end up just using this RGB. I think, so one of the things I was kind of talking about, so each one of these files is 36.2 megabyte here for the HA and the O3, but the RGB is 108.6 megabytes. So it is not the same size as these, which will cause problems. And so the extraction, my challenge is going to be, if I want to use the RGB, I need to get this to ultimately be a 16-bit image of the same size and dimensions as the other files that I want to work with. So the first thing I'm going to do then in Cyril is come over and set my home directory, which is already set for me. And then I want to open this RGB. Actually, I probably didn't need to open it, but so this RGB was one night. So anyway, what I'd like to do is go ahead and split this out. So I'm going to do an extraction and split channels, and I'm going to name each one. So I'll just call this R, this one G, and this one B, and apply. Now if I go into the home directory, I have the RGB files created for me here. And so each one of these is 36.2 megabytes. Which is the same as my HA and O3s, but that's with the channel split. So at some point in time, I could just decide that maybe I want to use just one of these channels and combine those or blend them. But again, I'm not exactly sure what I'm going to end up doing, but I wanted to have this flexibility to do that. So at this point, I am going to copy these into a new folder that I'll call processing. And so over here, these are the ones that I'll begin working with. And that allows me to go back and get to an original file at any point that I would like to. So from here, I'm going to do a background extraction on all these. So we'll go into Graxpert. And this is where the beauty of the new AI version in Graxpert really shows itself. So because it just makes it so quick with the AI. And I'm just going to start at the top and work my way down. We will have AI selected here and calculate background. And then I'm going to save processed. And that just appends Grexpert to it, which is fine with me. So we will go ahead and save. And I'm going to do that for each one of the other files. So now I just want to inspect and make sure I didn't make any mistakes there. So the B Grexpert, G Grexpert. Okay, and that all looks good. So at this point, I'm going to delete these copies of the originals that I made. And we'll just leave the Grexperts in here. All right. So yeah, that really is the beauty of Grexpert AI. It would have been, 30 minutes of doing background extractions for all those in Siril. And I do appreciate and like Siril background extraction, so don't get me wrong, but the convenience of what Grexpert can do there just really makes it easy. So at this point, I need to do like luminance, like leveling, and so I want to, let's see, I want to make sure first that my home directory is now my processing directory. And then I'm going to work on each one of these. And I'm actually going to start with the HA. Okay. And the next thing to do in this operation, so I am not going to crop yet, and actually it's questionable whether cropping is even needed. Maybe a little bit up at the top. It's really good. The alignment of my images has just been really good. But anyway, I'm going to go to linear, and I'm going to open up the statistics, and I'm interested in the median here. So we're going to level these all out based on the median value from a histogram stretch. So I'll open up histogram transformation, and we'll begin working with this. So I think that's where I'm going to set my target. So 10,206 will be the median value, which is basically the level of the ADU of the brightness or luminance of this image. So I will apply that. And I'm going to save. All right. And then I'm going to open up the O3 and do the same thing. And that's close enough. And then I'll do the same thing with the RGB. All right, and that will work. And I'll save that off. Okay, we should be done leveling now. So at this point in time, we can start messing around with some pixel math. So I will get into that. Okay, in the pixel math dialog, I have loaded up some expressions that I know were working for me through some experimentation that I had been doing. So my red is set for my H alpha channel at 90%. My green is 80% oxygen and 20% hydrogen. And my blue is 105% oxygen and 10% hydrogen. So a little outside the rules, but let's take a look and see how this works out for us. I also have some parameters set up here, and this is just kind of like a default. These values here aren't being used right now, but this tends to be pretty close to what I use. But if I do start using parameters up in my expressions, then I'll have these set up already. So the next thing I'm going to do is go ahead and load all my images. Okay, so images must have same dimension. So let's see. It did not load my RGB image. That's okay. I actually didn't want to select that one anyway. But it did load the individual RGB files and the hydrogen alpha and the oxygen. So I will go ahead and update these variable names here to B, G, H, O, and R. Okay, we should be able to hit apply now. All right, so we're getting close to doing a star removal, but I want to try to adjust the color on this a little bit before we do. And I'm going to do a negative transformation and a color calibration. It's hard to see, but I'm just selecting a background area. Then I'm going to select a large swatch of the nebula. And we'll apply that. Then I'll put that back. And then let me see, maybe we'll see if we remove green noise or not here. Yeah, I think so. Then I want to see what happens to bringing out the hydrogen and oxygen with color saturation. I'm not worried about the stars here because I'm actually going to discard them and use the OSC stars. All right, so with that, I think I'm going to, and I'll save this as a fit, and I will call it CC result, color calibration result. We'll save that, and I think we should go to 16-bit at this point. All right, and I want to open that. CC result, and we'll go ahead and do a StarNet processing on this. And this will take a little bit. All right, star processing has finished, and this looks pretty good right now. I'm not too worried about the background at this point. I don't want it to get too far away from me here, but I'll be able to do an adjustment layer in Photoshop and get this background sorted out. I think I will play with a little bit more color saturation. Just see what happens with the reds here. All right, it's a bit noisy, but we'll take care of that. I think at this point, I'm going to save this off. All right, I'm going to save this off as a TIFF. And I've prefixed it with PS for Photoshop. And we'll make that a 16-bit. It will be important to bring that back in and make a 32-bit fits of the Photoshop edited file when we're done, so that it will work with the StarNet recombination.
So over in Photoshop, let's open up that TIFF. And the first thing I'm going to do is going to duplicate a layer. So I've got my original. I'll name this working. And then I'm going to make a new color adjustment layer, which will be on the black layer. And let's fix this background up. And I'll do another one, and this one will be for the reds. And I'm going to make another one, which will be for the blues or cyan. I'll try blue first and see what that does. And let's look at the green channel. I don't know if this one will do anything, but we will see. Usually I get a little something out of the yellow and the green channel. Not seeing much of anything here though. Yeah, didn't do anything for me. Get rid of that. Alright, so I think at this point I'm going to go ahead and merge those layers. And just name that appropriately. I'm going to make that a smart object layer. Gives us some ability to come back in, edit this later if we need to. And I'm going to go into Camera Raw with this now. Probably nothing going to happen with the temperature or temp, but I always like to play with it a little bit just to see. The tint's actually working for me here. I think I'll give it just a little bit toward the cyan, or the magenta, I mean. Alright. See, I can bump up the exposure a little bit, and then come down here and adjust the black. I really like this kind of cloudy, dusty structure around the outside edge here. Try and pull a little bit of that back out. So we probably don't want texture. I'm going to pull that back, soften that up a little bit. Clarity. See, I really like, that's exaggerated, but I really like this detail around here. So I'm going to try and get at least some of that. Come up just a little bit, about right there. I think I'll leave that alone. Maybe bump the bright or the vibrance. And the saturation. I want to make sure I'm not, that things aren't breaking down here. It's kind of a matter of taste. I don't want to get it overly saturated with red, but there's a lot of hydrogen alpha here, so I do want to make sure it's predominant. I mess with curve, see what we get. Maybe push this and then go back to the darks again. Back here, basic. Yeah, that worked. And then we'll go to detail, and I will give this a slight bit of sharpening. Definitely not a lot, but just around 20, 21. And then I like to push the noise reduction and color noise reduction. That's pretty good. Not sure that there's much of anything I want to do with this anymore. So I think I'm good with that. These background kind of aberrations, if you will, these are stars. I think those are going to be okay when we get back in and do the recombination. I don't see a need to do anything with those at this point, so we will see how that actually turns out. Yeah, I'm going to go with that. And we'll save that as our TIFF. And we can go back to Serial and open that. I always like this part. We can kind of look at this now and then do a compare to what we've got. And we can see that transformation. So that's pretty cool. I like what's going on there. I will now, I want to save this to a FITS file at 32-bit. And at this point, I want to see about getting the stars from the OSC image. Make sure that's saved, and then I want to open, I think this is back over here. Here's the RGB. And I'm really just interested in the stars in this layer. I'm not going to do much with them here at all. So let's do another star processing on this image, and that should be good. So let's try that. Okay, so that OSC image star removal worked out fine. This OSC image was taken with a UV IR cut filter, and I think it would have had some good possibility to just do the entire set of sessions this way as well. But I do like where we're going otherwise. So anyway, I'm pretty much going to discard this side of the image, and I want to go and open up the starless RGB, or actually the star mask for the RGB, which is this one. And notice here, it's 106.6 megabytes. So this is, I need to get this to the same starless in this here, which is, oh wait, that's 106.6 also. So those are actually matching now. So let's open that. So here's my OSC star field. And let's go ahead and do a recombination and see if, or recomposition, I guess I should say, and see if these two come back together. And then I want to get that star mask from the RGB. All right. And this is good because there's a lot of color in the star field here. So I want to probably not do a whole lot at all with the nebula, but I want to tone down the star field. I'll start with black point on that. That'll help us in our background as well. Don't want to overdo it. I'm trying to balance in between the foreground and background here. And that looks like it's a pretty good spot right there. Just messing with it. And try and keep those aberrations in the background under control. I really like this star field. Just trying to get a balance here so it's not overpowering the nebula. But I do really like the color of the stars in this one. I'm glad I did that OSC session. I think I'm pretty happy with that. I'm going to apply. And let's just take a look and see what noise reduction does for us, if anything, or hurts us. We can just play here and see if wavelets add anything for us. This will probably be really small moves. Got a little bit bright in the middle. All right, I'm pretty happy with that. The stars need some work, and I'm thinking that AstroSharp is going to help me as far as those, like the star reduction is concerned. If we kind of pull in on those, yeah, they're just not. They're just a little not sharp. So I think that I mean, we are still resolving. Looks like, you know, like in here, we've got a double that's resolving. Okay. Okay, I'm going to save this off. It's currently unsaved star recomposition, so I'm going to call this final star recomposition. And we can save that as 16-bit. I'm also going to need to save a TIFF. To use in AstroSharp. All right, over here in AstroSharp, or Deep Sky D Tools, I'm going to go ahead and browse for that TIFF that I just created. And I want to use the hybrid model on this, so it'll use both AstroSharp and AstroClean. It's a color. We're looking at preview right now. You can really see these stars here. We're going to select multi-core processing. I generally just use the chunk size that's default. All right, so we need to figure out value for what 70% of PSF and FWHM. So let's go have a look over in Cyril and do some star measurements. 9.6, that's a bright one looking like. That's 22. So let's go with 70% of 10, I think. Can we do that? Yeah, so let's take this up to 7. And I'll leave aggressiveness about 60% here. All right, so let's update that and see what we kind of preview result we get. I'm going to bring this down just to compare. Maybe a little bit more aggressive. You can see how much sharper this preview is over here compared to this. If we look at this group here, compared. Well, let's give this a try. We'll go to full image. All right, so we can take a look. Yeah, I think that's done a good job. Let's go ahead and download the process file. Yeah, so one thing I still need to do that I forgot, I need to rotate this image, and we'll get it set up and oriented the correct way. But I think that I'm done with processing in this video. I might do some tweaks. I always end up revisiting stuff and after I look at it for a while and maybe messing around with things, but yeah. All right, so obviously it's the next day, and this was a marathon for me. I ended up getting tired last night and decided to put it on pause and resume here this morning. And anyway, I hope that you found some
ideas that you can use in your own processing, or some techniques and things that you thought were interesting. I think there were some unconventional things going on. This was a difficult one to process for me anyway. Every image is different, and so the processing techniques, and strategies that you use vary from image to image. But I think overall, you can take some ideas and try and apply them to your own to solve particular problems that you're trying to, or goals that you're trying to get to with your astro images. So hopefully, if you found this useful and interesting, then I hope that you'll give this video a like, and I'd love for you to subscribe. That would be awesome. So thank you very much, and here I present to you NGC 281 Pac-Man Nebula. My name is Doug, and this is Astro AF.